what does pre-stressing mean? Pre-stressing means applying a pre-compression to a member to offset the effects of applied loading. If you look at a concrete beam, which is shown here, usually after applying the load, this beam is going to bend like this. By using tensioned, high-strength steel bar like this, which is shown here, this beam is going to bend upward, as you can see here. There are two different methods for pre-stressing concrete beams. The first one is pre-tensioning. In this system, high-strength steel bar or cable has an initial tension, and the concrete is then placed around it. Once the concrete has achieved sufficient strength, the anchorage of tensioned steel is released, and the compression is applied to the concrete as the steel contracts. The second method for pre-stressing the concrete beams is post-tensioning. This method is the most common one in Australia. In this method, concrete is placed and achieves some degree of initial set before the tension is applied to the bar or cable. The high-strength steel is placed in the duct that is fixed to the formwork before the concrete is placed. The reason for using this duct is to separate the steel from the concrete. After the concrete has reached sufficient strength, jacks are used to apply the tension to cable. There are so many different post-tensioning systems used in the world. In Australia, we typically use bonded system, where grout is injected into ducts after the stressing is complete and loss due to friction and other effects are considered during the design. In our Rapt example, I'll show you how do we define this bonded system. The benefits of using post-tensioning for larger than 7 meter spans compared to a conventional reinforced concrete slab is that we're going to have thinner slab. Also, we can have longer span, which means we will have large column-free areas. Also, we're going to have lower deflection and also less cracks due to this tension applied in our concrete. In terms of design considerations, as per Australian code, which is AS 3600, we need to check our section for ultimate strength, which is bending moment and shear strength. Also, we need to check for serviceability, which includes short-term and long-term deflection checks. And also, we have to check for minimum steel requirement. For deflection check and crack control, we need to know that we have the same process that we have for reinforced concrete section. However, we need to consider the effect of pre-stress in balancing part of dead load and the fact that induced compression is going to significantly reduce or eliminate cracking in the section. For the crack control, we can look at table 9.5.2.3 of AS 3600, which is Australian standard for concrete design. From this table, you can get maximum increment of steel stress in pre-stressed slab. For example, here, if you know maximum crack width with the thickness of the slab, you can determine this stress. So let's assume our crack width is 0.3 millimeter and the thickness of our slab is less than 300 millimeter. So here you can see there are different values for different bar diameters, or you can use this value of 185 for all bonded tendons. When you know the value of stress, you can go to Rapt. In the design data section, there is a crack control part, and then on the top side, there is a maximum service stress change for pre-stressed sections. And then here you can put this value of 185 or whatever you get from this table.